The universe is hiding secrets that defy every textbook. We are about to journey through 30 of the most baffling, newly discovered oddities in space, each one a direct challenge to our fundamental laws of physics. You will see a cosmos far stranger and more wonderful than you ever imagined. How could a supermassive black hole be flung across the void? And what is the true cause of the growing crisis in cosmology itself? At the end of this tour, the familiar night sky will feel utterly transformed. What is the most surprising thing you believe is still waiting to be found out there? Our first oddity lies in a place of profound nothingness, the Boots Void. This is a region of space so staggeringly empty it could fit thousands of galaxies, yet holds only a handful. Within this cosmic desert, astronomers have found something even more perplexing. A colossal patch of cold known as the Great Cold Spot, etched into the oldest light in the universe. This isn't just a slightly cooler area. It's a massive, distinct anomaly in the cosmic microwave background, the faint afterglow of the Big Bang itself. Standard models of the universe's evolution struggle to explain its existence. Something on a truly gigantic scale must have carved this frigid imprint into the fabric of space-time when the cosmos was still in its infancy. One radical theory suggests it could be the bruise from a collision with a bubble universe from another dimension, a cosmic crash of unimaginable proportions. Another idea points to a defect in the structure of the early universe, a giant cosmic texture that left a permanent cold signature as it unraveled. This great cold spot is our first clue that the universe's infancy might have been far more turbulent and far stranger than our smoothest models predict. That cosmic cold spot is not the only wanderer defying expectations. Our second oddity is an object that should be anchored at the very heart of a galaxy, but instead it is on a solo journey through the void. The Hubble Space Telescope captured something extraordinary, a supermassive black hole with a mass of 20 million suns racing across intergalactic space. It is not traveling alone, however. Behind it stretches a breathtaking bridge of light, a 200,000 light-year long trail of newborn stars. Picture a cosmic gardener plowing through the darkness and sowing seeds of starlight in its wake. This is not the serene, all-consuming monster we imagine a black hole to be. This one is a catalyst for creation. The explanation is as dramatic as the scene itself. Astronomers believe this began with a violent celestial dance involving 3 galaxies. As their central supermassive black holes swirled toward each other, 2 of them likely merged into a binary pair. When the third black hole entered the fray, the complex gravitational forces acted like a cosmic slingshot, violently ejecting one of the trio at incredible speed. The runaway black hole now plows through the thin gas that permeates intergalactic space. This gas is compressed and shocked by the black hole's passage, cooling and collapsing directly into brilliant young stars. This discovery shatters the simple image of black holes as mere destroyers. Here, a supermassive black hole has become an accidental architect, building a luminous highway across the cosmos. What other roles might these gravitational giants be playing in the shadows of the universe? This runaway star forger shows that our telescopes can still be utterly surprised by the sheer scale of cosmic phenomena. That brings us to our third oddity, a discovery so baffling that astronomers literally named them what they are: odd radio circles. These are not small. They are colossal, faint rings of radio emission, some so vast they could contain multiple galaxies within their borders. The truly strange part, they are completely invisible in optical, infrared, or X-ray light. They exist only as ghostly halos in the radio portion of the spectrum, discovered by the ASCAP telescope in Australia. At first, researchers thought they might be imaging artifacts or familiar objects like the remnants of a supernova explosion. But these circles are far too large and too perfectly circular. They are also not Einstein rings, the warped light from distant galaxies. These are something entirely new. So what could possibly create such enormous ephemeral structures? One leading idea involves spherical shockwaves. Imagine a titanic event at a galaxy's center, like a burst of star formation or activity from a supermassive black hole, sending a powerful galactic wind screaming into intergalactic space. That wind could push outwards in a near-perfect sphere, creating a shockwave that accelerates electrons, causing them to glow in radio waves as they travel. This would be like seeing the faint, circular echo of a galactic-scale explosion from eons past. An even more exotic hypothesis suggests we might be looking at the throats of wormholes. Theoretical physics allows for the possibility of tunnels through space-time, and some models predict that the mouths of these tunnels could emit specific radio signatures. While this remains a speculative long shot, it highlights just how mysterious these circles truly are. To look at an optical image of that patch of sky is to see nothing unusual, just a scattering of normal galaxies. But switch the view to radio waves and a perfect celestial ring emerges from the darkness, a silent and gigantic question mark hanging in the deep. These ghostly radio circles are a mystery written in a language of invisible light, but our next oddity speaks in the ancient language of chemistry, etched into the heart of a single, impossible star. In the constellation Sextans, a red giant named J0931 plus 0038 burns with a secret. When astronomers pointed their spectrographs at it, they were not just measuring its light, they were reading its life story written in the precise wavelengths it absorbs. Every star has a chemical fingerprint, a unique blend of elements forged in its own core or inherited from the stellar explosion that birthed it. This star's fingerprint is all wrong. It is a cosmic anomaly of bizarre proportions. The data showed staggeringly low levels of expected elements like magnesium and aluminum, while other, heavier elements like nickel, zinc, and even yttrium were present in amounts that defy all logic. It is as if you baked a cake following a familiar recipe, but when you cut into it, you found it contained traces of rare metals and was missing all the flour. This pattern does not match the debris from any known type of supernova, the colossal explosions that seed the galaxy with new elements. It does not align with the quiet death of a white dwarf or the cataclysmic merger of neutron stars. The material that coalesced to form this star came from something else entirely, a progenitor star that must have died in a way we have never seen and do not yet understand. This suggests a completely unknown class of stellar explosion, one with physics so extreme it created this specific, freakish cocktail of elements before scattering them into a cloud that would one day become this red giant. J0931 is a solitary artifact, a fossil from a forgotten chapter of stellar evolution. It is not just a weird star, it is a piece of evidence pointing to a gap in our understanding of how the universe forges the very stuff of matter. That strange stellar chemistry hints at a universe capable of forging matter in ways we have yet to comprehend, but the surprises are not confined to the distant past. They are happening right now in planetary systems that look nothing like our own. Astronomers have found entire worlds that defy the very definition of a planet, objects so insubstantial they have earned the nickname cotton candy planets or super puffs. In the Kepler 51 system, over 2,000 light-years away, 3 such worlds orbit a young, sun-like star. They are the cosmic equivalent of a physics riddle. Each one has a mass only a few times greater than Earth's, but they are bloated to the size of Jupiter. If you could somehow place one of these planets in a cosmic ocean, it would float. Their density is less than 1/10 of a gram per cubic centimeter, which is actually lower than cotton candy you might eat at a fair. They are not solid, rocky bodies like Earth, nor are they gas giants like Jupiter. They are something entirely different, gigantic, fluffy atmospheres held together by a whisper of gravity. The central mystery is how these tenuous worlds exist at all. They orbit very close to their star, well within the orbit of Mercury in our own solar system. At that distance, the intense stellar radiation and powerful stellar winds should have ripped those puffy atmospheres away into space billions of years ago, leaving behind only a barren, rocky core. Yet there they are, intact. The leading theory is that these are not permanent features, but a fleeting teenage phase in a planet's life. They might be young, Neptune-like worlds that are still cooling and contracting from their formation. As they cool, their massive primordial atmospheres of hydrogen and helium could be slowly escaping, creating an extended, hazy shroud that makes them appear much larger and fluffier than they truly are. We are catching them in a brief window of cosmic time, watching them literally evaporate before our eyes. Another idea points to rings. Perhaps these planets are surrounded by colossal systems of rings and moons, like a super-sized version of Saturn, and the light we see is filtering through this debris, making the planet seem artificially inflated. Whatever the answer, these cotton candy worlds force us to rewrite the catalogue of what is possible. They show us that a planet can be a temporary, gossamer thing, a giant cloud with a tiny heart, existing in a state that our own solar system never prepared us to find. The fleeting beauty of a cotton candy planet shows how delicate a world can be. But what happens to a structure 1,000,000 times larger when its most essential ingredient simply vanishes? Our sixth oddity is a ghost of a galaxy named NGC 1052DF2. In deep field images, it appears as a faint, wispy smudge of light, an ultra-diffuse galaxy so translucent you can see right through it to the galaxies beyond. Its stars are spread so thin it looks more like a cosmic cloud than a coherent island of stars. But its true strangeness is not its appearance, it is what is missing. According to every established rule of cosmology, dark matter is the invisible scaffolding of the universe. This mysterious substance, which does not emit or reflect light, provides the gravitational glue that holds galaxies together. Without a massive halo of dark matter anchoring them, the visible stars in a typical galaxy would simply fly apart due to their own orbital speeds. Yet when astronomers meticulously measured the motions of 10 globular star clusters orbiting NGC 1052DF2, they received a shock. The clusters were moving surprisingly slowly. From their speed, scientists could calculate the total mass of the galaxy holding them in place. The result was staggering. The mass they calculated from the motions matched almost exactly the mass they could see in the form of stars. There was no room left for dark matter. This galaxy, for all intents and purposes, appears to be made of normal, baryonic matter alone. It is a cosmic heresy. The immediate question is devastatingly simple. How did this happen? One compelling theory involves a violent past. NGC 1052DF2 lies near a massive elliptical galaxy. It is possible that long ago it ventured too close. As it passed through the dense intergalactic gas surrounding the larger galaxy, or felt the immense pull of its gravity, all of its own dark matter could have been brutally stripped away, leaving behind only the visible stars, which are more tightly bound and harder to remove. It would be like having a crowd of people, the stars, held together by a giant, invisible net, the dark matter. If something came along and ripped the net away, the people would remain, but the structure that truly held them as a group is gone. Another, more radical interpretation is that this galaxy is evidence against dark matter itself. Perhaps our laws of gravity work differently on galactic scales, and we do not need an invisible substance to explain what we see. But most scientists see NGC 1052DF2 not as a refutation, but as a crucial clue. It tells us that dark matter is not inseparably fused to the stars. It can be separated. This means dark matter is a real, physical thing that interacts with the universe primarily through gravity, and that it can be lost. Finding a galaxy without it is like finding a car without an engine. It forces us to understand what the engine is, how it works, and how it can be removed. This ghostly, transparent smudge is therefore one of the most important discoveries in modern astronomy, a silent challenge that asks us to rewrite the story of how galaxies live and die. The discovery of a galaxy seemingly devoid of dark matter reveals a cosmos where even the fundamental rules can have startling exceptions, but some rules appear to be broken with a precise, almost mechanical regularity. Deep in the constellation Auriga, a cosmic lighthouse is flashing on a strict schedule. This is fast radio burst 121102, the first of its kind to reveal a predictable heartbeat. Fast radio bursts are among the most energetic and mysterious events in the universe, brief blasts of radio waves that release more energy in a millisecond than our Sun does in 80 years. Most appear as single, catastrophic one-off events, likely caused by the violent mergers of dense stellar corpses like neutron stars, but a handful, like 121102, repeat. And this one does not just repeat randomly. For 157 days it remains silent. Then, for roughly 90 days, it erupts in a storm of brilliant flashes before going quiet again. This perfect, months-long cycle of activity and silence is a profound clue. It tells us this incredible energy is not being generated by a chaotic collision, but by a system, a cosmic clockwork with moving parts. The leading model to explain this rhythmic beacon is as elegant as it is extreme. Imagine a highly magnetized, rapidly spinning neutron star, a pulsar. This city-sized remnant of a supernova is like a spinning top, but if that top is wobbling or precessing, its beam of radiation sweeps across the sky like a lighthouse. Now place that wobbling pulsar in a long, elliptical orbit around a massive companion, perhaps another neutron star or a black hole. As the pulsar travels along its elongated path, there are periods when its precessing beam is pointed toward Earth and we see the brilliant flashes. Then, as it moves to the far side of its orbit, or its wobble takes the beam away from our line of sight, the bursts cease. The 157-day cycle would then be the orbital period of this entire dance. It is a celestial mechanism of breathtaking precision and power, where the interplay of spin, wobble, and orbit creates a timetable written across intergalactic space. This repeating signal is more than a mystery, it is a message. It tells us that within these bursts lies the fingerprint of an environment governed by strict orbital mechanics, offering a rare window into the physics of the most extreme objects in nature, all blinking on and off according to a calendar we can finally read. That cosmic clockwork of repeating radio bursts reveals a universe governed by precise, if extreme, laws, but some stars seem to operate by rules of their own. One star in particular has become a legend for its refusal to behave, a star whose name is now synonymous with cosmic mystery, KIC 8462852, often called Boyajian star. Located over 1,000 light-years away in the constellation Cygnus, this otherwise ordinary star has captivated astronomers and the public alike with its impossible light. Data from the Kepler Space Telescope revealed its bizarre signature, not the gentle, periodic dip of an orbiting planet, but a series of deep, irregular, and asymmetric plunges in brightness. At times, the star's light would drop by a staggering 22%, a depth that means something truly colossal is blocking its face. The most famous early hypothesis was as thrilling as it was unlikely. A Dyson sphere, a hypothetical swarm of energy-collecting structures built by an advanced civilization encircling the star. While that idea captured imaginations, science has moved forward with more grounded, yet still profoundly strange explanations. Newer observations, including recent data from the Los Cumbres Observatory Global Telescope Network, continue to show these bizarre dimming events. The light curve graphs are dramatic, showing not smooth U-shaped dips but jagged, precipitous drops and uneven recoveries, as if whatever is passing in front of the star has an incredibly complex and clumpy structure. One leading theory points to a giant, fragmented swarm of exocomets, Imagine a family of comets, perhaps disrupted by a passing star, breaking into a vast cloud of dust and debris on a long, elliptical orbit. As this swarm passes in front of the star, its uneven distribution would create those irregular, deep dimmings. Another idea suggests the debris could be from a cataclysm on a planetary scale, like the collision and shattering of an entire world or moon, creating a colossal field of dust and rubble that now periodically eclipses its parent star. There is also the possibility of intrinsic stellar variability, that the star itself is undergoing some rare form of magnetic activity or pulsation that causes its brightness to plummet in these strange ways. Yet none of these explanations fit the data perfectly. The sheer depth and irregularity of the dips remain a formidable puzzle. Boyajian's star stands as a testament to the fact that even when we rule out aliens, the universe retains a capacity for wonder that outstrips our imagination. It is a reminder that our catalogue of cosmic phenomena is still incomplete, and that sometimes the most compelling mysteries are not about what we can explain, but about what stubbornly, brilliantly refuses to be explained. Boyajian's star is a mystery of light, of something blocking the view. But what if the ultimate cosmic oddity is not something that blocks, but something that pushes? The universe is not just expanding, it is accelerating, driven by a mysterious force we call dark energy. Now, a radical idea suggests this same force might be locked inside individual stars, creating objects that could rival black holes for the title of universe's most bizarre phenomenon, dark energy stars. This is not science fiction, but a serious, if controversial, theoretical proposal. The concept turns the idea of a black hole inside out. According to Einstein's theory, when a massive star collapses, its matter crushes down into an infinitely dense point called a singularity, hidden behind an event horizon from which nothing, not even light, can escape. A dark energy star proposes a different fate. Instead of collapsing to a singularity, the dying star reaches a point where its core transforms into a bubble of pure dark energy. This exotic energy exerts a powerful negative pressure, a kind of cosmic repulsion that halts the collapse. The result is an object that looks almost exactly like a black hole from the outside, with intense gravity and a shadow-like appearance, but with no singularity and, crucially, no event horizon. It would be a star made of the very stuff that is tearing the cosmos apart at the seams. For years, this was pure mathematical speculation, until gravitational wave astronomy gave us a new way to listen to the collisions of the universe's heaviest objects. The event known as GW1 90521 was a landmark detection. It came from the merger of two colossal objects, one about 85 times the mass of our Sun, the other around 66 solar masses. The result was a final black hole of about 142 solar masses. The problem lies with that first object. According to our understanding of stellar evolution, stars between about 65 and 130 solar masses should undergo a process called pair instability, where matter and antimatter creation in their cores triggers a runaway reaction that blows the star apart completely, leaving no remnant behind. An 85 solar mass black hole should not exist because the star that formed it should have annihilated itself. This is the impossible mass gap. Could GW 190521 have been the collision of two dark energy stars instead? Proponents of the idea suggest it might fit. If dark energy halts collapse, it could allow remnants to form in that forbidden mass range, sidestepping the pair instability problem entirely. The gravitational waves from such a merger would be subtly different from a black hole collision, perhaps in the ring-down phase, the final vibrations as the new object settles into a stable form. While current data from LIGO and Virgo still strongly favors the black hole interpretation, the anomaly of the mass gap leaves a door open. It invites us to wonder if some of the dark shadows we think are black holes might actually be something even stranger. Not ultimate pits of gravity, but sealed containers of the force that is pushing the entire universe apart. The idea of stars made from dark energy pushes our imagination to the limit, but sometimes the strangest objects are not theoretical, they are visitors. In October 2017, telescopes in Hawaii detected a faint point of light moving at breathtaking speed. It was not from our solar system. It was our first confirmed interstellar visitor, an object from the depths of the galaxy, and we named it Oumuamua, Hawaiian for scout. Its brief passage was a scientific sensation, and its peculiarities only deepened the mystery. Initial observations revealed an object with no detectable coma, the fuzzy envelope of gas and dust that surrounds active comets. It was also tumbling chaotically, and most strikingly, it appeared to be highly elongated, perhaps 10 times longer than it was wide, shaped like a cosmic cigar or a pancake. But the true oddity, the one that ignited fierce debate, came as it was leaving. As Oumuamua sped away from the sun, something was wrong with its trajectory. Precise measurements showed it was accelerating, deviating from the path dictated purely by the sun's gravity. This non-gravitational acceleration was subtle but definitive. Something besides gravity was giving it a tiny push. For comets, this is common, caused by outgassing. As sunlight heats a comet's icy surface, jets of vapor erupt, acting like natural thrusters. The problem was, Oumuamua showed no visible signs of outgassing. No dust tail, no gas cloud, nothing. So what was pushing it? The scientific community scrambled for answers. One leading natural explanation involves hydrogen ice. If Oumuamua was a chunk of molecular hydrogen ice, a substance that forms only in the coldest depths of interstellar space, then as it approached the sun, the ice would have sublimated directly from solid to gas. Hydrogen is invisible to our telescopes, so this outgassing would explain the acceleration without a visible coma. It is an elegant solution, though it requires a very specific and fragile type of object to survive a long interstellar journey. The more speculative and headline-grabbing hypothesis came from Harvard astronomer Avi Loeb. He proposed that the acceleration could be explained by radiation pressure from sunlight itself. For that to work, Oumuamua would need to be extremely thin and light, like a sheet of material less than a millimeter thick. In essence, it would behave like a light sail, a technology our own species is beginning to develop for spacecraft propulsion. This idea, while not the consensus, asked a profound question. Could Oumuamua have been an artifact, a discarded piece of an alien civilization's technology, a broken solar sail drifting between the stars? Imagine trajectory diagrams of its flight through our solar system. The line predicted by gravity alone is a smooth curve. The actual observed path shows a slight but clear kink as it departs, a nudge from an unseen force. This tiny deviation is the heart of the mystery. Whether it was an exotic iceberg of hydrogen or a relic of a distant intelligence, Oumuamua's acceleration forces us to confront the sheer diversity of objects that must be sailing the galactic seas, unseen and unknown. It was a scout in the truest sense, giving us a single, tantalizing glimpse of the raw material of other star systems, and in doing so, revealing how much we have yet to learn about what travels in the darkness between them. Oumuamua's silent departure left us wondering what else might be hiding in plain sight, and sometimes the most startling discoveries are not visitors, but structures we have overlooked for years in our own cosmic backyard. Our 11th oddity is a set of faint, ghostly circles etched in the highest energy light the universe produces. For over a decade, astronomers have known about the Fermi bubbles, two colossal orbs of gamma-ray light extending above and below the center of our Milky Way. They are like a giant, hourglass-shaped monument to some ancient cataclysm. But recently, while sifting through data from the Fermi Gamma-Ray Space Telescope, researchers spotted something new, two additional, even larger and much fainter circles. These structures are not connected to the famous Fermi bubbles. They float separately in the galactic data, vast and diffuse halos of gamma radiation that form near-perfect rings on an all-sky map. To visualize this, imagine looking at a map of the entire sky in gamma rays. At the center, you would see the bright band of the Milky Way's disk. Emanating from the core are the distinct, bright Fermi bubbles. And now, superimposed on that, are these two enormous, faint circles like ripples in a pond, each one spanning an incredible portion of the heavens. They are so large and so dim that they were only found by carefully subtracting all other known sources of gamma rays, revealing the subtle, circular patterns that had been hiding in the noise all along. Their origin is a profound puzzle. One compelling theory connects them to the sleeping giant at our galaxy's heart, the supermassive black hole named Sagittarius, a star. While it is quiet now, it may not have always been so. These ghostly circles could be the fading remnants of a titanic eruption that occurred millions of years ago. In this scenario, the black hole would have experienced a period of ferocious feeding, devouring vast amounts of matter. The incredible energy released could have blasted out jets or winds at near light speed, which then plowed into the halo of gas surrounding the Milky Way. That collision would create a spherical shockwave, accelerating particles to extreme energies and causing them to glow in gamma rays for eons after the initial explosion subsided. We would be seeing the faint, fossilized echo of our black hole's violent past. Another possibility is even more dramatic. These circles might be the cosmic scars from a galactic merger. Billions of years ago, a small dwarf galaxy could have been cannibalized by the growing Milky Way. As it was torn apart, its final death throes might have sent powerful shockwaves through the galactic halo, creating these lasting spherical imprints. It would be like seeing the ghostly outline of a long-digested meal still visible in our galaxy's stomach. What makes these circles so intriguing is their scale and symmetry. They are not messy blobs or jets, they are coherent circular structures, suggesting a single, powerful, and symmetrical event. They force us to reconsider the history of our own galactic home. We tend to think of the Milky Way as a stable, serene spiral, but these faint gamma-ray halos are a silent testament to a far more violent and dynamic past. A past where the center of our galaxy roared with energy and smaller galaxies were consumed in cosmic collisions. They are a reminder that even our most familiar stellar neighborhood has secrets, written not in starlight, but in the faint, high-energy glow of ancient explosions. These faint gamma-ray circles speak of ancient galactic violence, but chaos can also be found in the cradle of a newborn star system. The constellation of Orion holds a stellar nursery named GW Orionis, and here we find a planetary construction site gone terribly wrong. This is not a single star, but a triple star system, 3 young suns engaged in a complex gravitational dance. Around them should be a flat, orderly disk of gas and dust, the raw material for building planets. Instead, the Atacama Large Millimeter Array Telescope revealed a disk that looks like it has been put through a cosmic shredder. The outer ring of dust is tilted at a wild angle, completely misaligned with the orbits of the stars themselves, and it is physically torn apart from the inner rings by a vast, shadowy gap. This gap is the key. Within that emptiness, something massive is clearing a path. The gravitational pull required to carve out that space and warp the entire disk points to one incredible possibility: a planet in the act of formation, or perhaps already fully formed, orbiting within this triple star chaos. To visualize this, you must abandon any notion of a flat solar system like our own. Picture 3 young stars, 2 locked in a tight binary embrace with a third orbiting farther out. Now imagine not a single dinner plate disk, but a series of dusty rings, each tilted and warped at different angles like a broken gyroscope, all encircling this stellar trio. Within the largest gap between rings, a fledgling world struggles to coalesce. The gravitational forces at play here are immense and conflicting. The competing tugs from 3 different stars would create zones of extreme instability, regions where the gentle accumulation of planetesimals would be constantly disrupted. For a planet to form here, it must either be a rapid, almost violent process, or it must find a narrow, sheltered orbit where the gravitational influences somehow cancel out into a temporary stability. Astronomers call this the disk-tearing model. The gravitational torque from the misaligned stars literally rips the once coherent disk into these distinct warped rings. The planet itself may be responsible for carving the gap, its gravity sweeping its orbit clear as it grows. This means we could be looking at the first direct evidence of a circumtriple planet, a world that orbits all three stars at once. Its sky would be a spectacle of perpetual drama, with multiple suns rising and setting in a complex, ever-changing ballet. The very existence of such a planet challenges our most fundamental models of how solar systems are born, proving that planets can form in environments of breathtaking gravitational turmoil, emerging from a disk that looks less like a nursery and more like a cosmic crime scene. While some stars are torn apart by their companions, others become the predators. In the constellation Sextans, a cosmic spider spins a deadly web of radiation. This is the Black Widow pulsar known as PSR J09520607, a rapidly spinning neutron star that completes over 700 rotations every single second. Like its namesake Arachnid, this pulsar is consuming its partner. It orbits a tiny, incredibly dense stellar remnant, a former star that has been whittled down by relentless blasts of high-energy particles to a mere fraction of its original mass. This companion now weighs less than 20 times the mass of Jupiter, essentially a planet-sized cinder orbiting a city-sized powerhouse. The relationship is brutally one-sided. The pulsar's intense magnetic field and radiation strip material from its tiny companion while also bombarding it with a wind of particles, slowly but surely evaporating it into oblivion. This dance of destruction is fascinating, but it is not the primary reason this system is an oddity. The true mystery lies in the spider's own weight. Using the exquisite timing of the pulsar's radio ticks, astronomers have measured its mass with incredible precision. The result is staggering. This neutron star weighs at least 2.35 times the mass of our Sun, placing it right at the very upper edge of what our theories predict is possible for such an object. This is the heaviest neutron star we have ever reliably measured, and its existence is pushing physics to a breaking point. Neutron stars are the collapsed cores of massive stars, so dense that a single teaspoon of their material would weigh as much as a mountain. The matter inside is in a state that does not exist anywhere else in the universe, a quantum soup of neutrons packed together with almost no empty space. For decades, physicists have calculated a theoretical upper limit for this density, a point known as the Tolman-Oppenheimer-Volkoff limit. Beyond this mass, the inward crush of gravity should overcome the quantum forces that keep neutrons apart, causing the entire star to collapse further into a black hole. PSR J09520607 is now brushing against that limit. Its immense mass suggests the core of a neutron star might be even stranger than we thought. Perhaps under such unimaginable pressure, neutrons themselves break down into a sea of their constituent quarks, creating a new form of matter known as quark-gluon plasma. Or maybe exotic particles like hyperons form in the core, changing the equation of state that determines how much pressure the star can withstand. This black widow is not just a celestial predator, it is a natural laboratory. By weighing it, we are weighing the fundamental forces of nature at their most extreme. Each precise radio pulse is a message from the edge of oblivion, telling us how much mass can be piled onto a sphere of quantum matter before the universe itself says enough. The immense weight of a single neutron star tests the laws of physics at their limit. But what if the entire observable cosmos is being pulled by a force from beyond its own borders? This brings us to one of the most contentious ideas in modern cosmology, the phenomenon known as the dark flow. Over a decade ago, astronomers studying the cosmic microwave background made a startling claim. By tracking the motion of massive galaxy clusters, they detected a subtle but consistent bulk flow. It was as if thousands of these colossal structures were all drifting in the same specific direction, like leaves caught in a gentle cosmic current. The problem is, according to our standard model of the universe, there should be no such preferred direction on such a vast scale. The distribution of matter after the Big Bang should be statistically uniform, meaning any motion of clusters should be random, cancelling out into a general expansion. This dark flow suggested something else entirely, a coherent tug on a significant portion of the observable universe. The implication was staggering. It pointed to the gravitational influence of something unimaginably vast that lies beyond the cosmic horizon, beyond the part of the universe we can ever see. One radical interpretation proposed it was the pull of another universe, a neighboring bubble in a vast multiverse, exerting its gravity on our own. Others suggested it could be caused by a titanic, unseen concentration of mass, a structure so enormous it defies our current maps of the cosmos. For years, the dark flow remained a controversial outlier, with many scientists attributing the signal to measurement errors or unaccounted for systematic effects. The debate required better data. Enter new surveys like eROSITA, an X-ray telescope designed to map the hot gas in galaxy clusters with unprecedented precision. By studying the kinematic Sunyaev-Zeldovich effect, a subtle distortion in the cosmic microwave background caused by clusters moving through it, these new instruments are putting the dark flow to a more rigorous test. The latest analyses present a complex picture. Some studies using these advanced datasets still find evidence for a residual bulk flow, though its statistical significance is hotly debated. Other analyses suggest the signal diminishes or becomes consistent with noise when more complete models of cluster physics and larger samples are used. The controversy is not yet settled. What makes the dark flow so profoundly important is not whether it definitively exists, but what its mere possibility forces us to confront. If confirmed, it would be the first empirical hint that our universe is not an isolated island. It would imply that our cosmos is embedded within a far grander structure, one where influences can leak from one domain to another. We would have to accept that the totality of reality extends far beyond the 14 billion light-year radius we call the observable universe, and that we are not floating in a void, but are perhaps part of a much larger and utterly foreign cosmic geography. Even if the dark flow is ultimately refuted, the search for it has already expanded our imagination, challenging us to consider that the greatest structures and forces in existence may forever lie just beyond the edge of our sight. That search for hidden geography leads us to a structure so geometrically perfect it looks deliberately crafted. Suspended in the constellation Monoceros over 2,000 light-years from Earth, the Red Rectangle Nebula is a cosmic anomaly of breathtaking symmetry. The Hubble Space Telescope captured its iconic image, revealing not a chaotic cloud of gas, but an intricate lattice of glowing red lines that form a near-perfect X-shape, framed within a rectangular envelope of dust. At its heart lies a binary star system, HD 44179, where a dying red giant is slowly expelling its outer layers into space. The puzzle is how a spherical star can produce such crisp, linear structures. The answer lies in perspective and physics. Astronomers believe the dying star is not ejecting material in a uniform sphere, but in two opposing cones of gas and dust, like twin ice cream cones placed tip to tip. We are viewing this double cone structure almost perfectly edge-on. From this side-on angle, the thick walls of the cones appear as the two diagonal lines of the X, while the accumulated dust at their edges creates the faint rectangular outline. But the red rectangle's symmetry goes even deeper. Hubble's sharp vision resolved the red lines not as solid beams, but as a series of precise, evenly spaced rungs like a luminous ladder. This remarkable regularity is thought to be caused by pulsations from the central star. Every few hundred years, the star may undergo a thermal pulse, a brief surge in energy that sends a new shell of material expanding outward. As successive shells are ejected and collide with the slower-moving gas from earlier pulses, they create those distinct periodic steps. It is a natural strobe light, etching a record of its own heartbeat into the nebula's structure. The rich red color itself is a clue, emitted not by glowing hydrogen, but by a rare class of carbon-based molecules known as polycyclic aromatic hydrocarbons illuminated by the starlight. This object is therefore a temporary masterpiece, a fleeting alignment of geometry, timing, and chemistry. In a few thousand years, the central star will heat up further, illuminating the expelled gas into a more traditional planetary nebula, and this perfect red X will dissolve into the void. For now, it stands as a stunning reminder that natural processes viewed from just the right angle can create art of mathematical precision, challenging our instinct to see design in the deep cosmos. Geometric perfection in the cosmos is rare, but raw, unfiltered power is not. In the constellation Monoceros, not far from the serene red rectangle, burns a star that defies the very laws governing stellar magnetism. This is HD 45166, a massive Wolf-Rayet star, and it is a monster. Recent observations have revealed it possesses a magnetic field of almost unimaginable strength, measuring 1,000 billion times more powerful than the magnetic field of our own Sun. This is not just a strong magnet, it is the strongest magnetic field ever detected for a star of its type, and its existence is sending shock waves through our understanding of how the most massive stars live and die. Wolf-Rayet stars are the volatile, helium-burning cores of former giants, having shed their outer hydrogen layers in furious stellar winds. They are already extreme objects, but finding one with a magnetic field this intense is like discovering a hurricane with a perfectly structured metallic core. It simply should not be possible according to standard models. For a magnetic field this strong to exist in such a star, it must have been baked in from the very beginning, frozen into the star's material during its formation, or generated by a violent merger of two precursor stars. Picture the star not as a simple ball of gas, but as a seething sphere wrapped in a cage of invisible, impossibly dense magnetic field lines. These lines erupt from the surface, arcing through the star's blistering winds, channeling and controlling the flow of material into space. This magnetic prison is so potent it forces the star's entire outflow into a rigid structure, shaping its demise. This discovery transforms HD 45166 from a curiosity into a cosmic prophecy. Astronomers now suspect it is a direct progenitor, a blueprint for one of the universe's most enigmatic objects, a magnetar. Magnetars are a special class of neutron stars, the collapsed remnants of supernova that possess magnetic fields 1,000 times stronger still. They are the universe's ultimate magnets, capable of producing starquakes that release more energy in 1/10 of a second than our Sun emits in 100,000 years. HD 45166 provides the missing link. It shows us that the seeds of a magnetar's incomprehensible power are sown long before the star explodes. This magnetic monster is currently in its final act, burning through its fuel at a ferocious rate. In a cosmic blink, it will exhaust itself, its core will collapse, and it will detonate in a supernova. But its magnetic legacy will not be destroyed. During that collapse, the stars frozen in magnetic field will be squeezed, concentrated, and amplified beyond measure. What emerges from the ashes will not be an ordinary neutron star, but a newborn magnetar, a celestial powerhouse whose magnetic grip can distort atoms across light years. This star is a living fossil, a preview of a terrifying future, proving that the most violent forces in the universe are not born in chaos, but are written into a star's destiny from its very first breath. That magnetic monster will forge a legacy of unimaginable force, but the aftermath of a supernova can also create a pure projectile. In the constellation Cassiopeia, a cosmic bullet is screaming through the void. This is PSRJ 0002 plus 6216, a pulsar moving at a velocity that defies belief, over 2.5 million miles per hour. At that speed, you could travel from Earth to the Moon in under 6 minutes. This isn't just a fast-moving star, it's a runaway, and it has left behind a perfect, incriminating trail. Data from the Fermi Gamma Ray Space Telescope and the Very Large Array Radio Telescope revealed a breathtaking scene. The pulsar itself is a tiny, spinning point of intense radiation, but streaming behind it, like the glowing tail of a comet, is a long, narrow jet of high-energy particles. This tail doesn't drift aimlessly, it points like a perfectly straight arrow directly back to the heart of a supernova remnant named CTB1. The geometry is undeniable. This pulsar is the smoking gun fired from the cosmic crime scene of its own birth. The sheer violence of its escape is measured in its kick velocity, the speed imparted to a neutron star during the supernova explosion. Most pulsars receive a kick, but this one is extreme, ranking among the fastest ever measured. To achieve such a velocity, the explosion that birthed it could not have been symmetrical. Imagine a standard firework exploding evenly in all directions. The casing might just fall apart. But if one side of the firework is much more powerful, the casing is shot out in the opposite direction. This pulsar is that casing. Astronomers believe its incredible speed is the result of a profoundly lopsided supernova. As the progenitor star's core collapsed, neutrinos, those ghostly, nearly massless particles, may have been emitted in a powerful, one-sided flood. This neutrino rocket effect, combined with possible imbalances in the detonation itself, could have acted like a natural cannon, blasting the newborn neutron star clear of the debris. The pulsar has now traveled over 50 light-years from its point of origin, and its tail provides a chronological record of its journey. We can trace its path backward through time, watching as the tail widens and disperses the closer we get to the remnant, like seeing the wake of a speedboat fade into the distance. This cannonball pulsar is more than a curiosity, it is a forensic tool. By studying its trajectory and speed, we can reverse engineer the last moments of that ancient star's death, understanding the hidden asymmetries that turn a stellar collapse into the ultimate particle accelerator, launching a city-sized remnant across the galaxy at a fraction of the speed of light. A cannonball pulsar charts a violent path across the galaxy, but some of the universe's most massive objects leave no visible trail at all. Our 18th oddity is a ghost, a galaxy that might be composed almost entirely of dark matter, and we found it not by seeing it, but by watching it bend a whisper from across the cosmos. The clue came from a single milliseconds-long fast radio burst named FRB 2019050B. As this brilliant flash of radio waves traveled over 4 billion light-years toward Earth, something subtle happened to its signal. When astronomers analyzed its light, they found it had been slightly but distinctly distorted. This distortion is the signature of gravitational lensing, one of Einstein's great predictions. Just as a glass lens bends light, a massive object's gravity warps the fabric of space-time, curving any radiation that passes nearby. The effect on the fast radio burst was incredibly faint, but it was measurable. The burst's single pulse appeared to have been duplicated and smeared in a specific way, indicating a massive lensing object between us and the burst source. The puzzle arose when they pointed every available telescope at that precise spot in the sky. There was nothing there, no visible galaxy, no cluster of stars, not even a faint smudge of light. Yet the lensing signal insisted that a colossal mass was present, one capable of bending light. The mathematics pointed to a staggering conclusion. The mass required to create that lensing effect was equivalent to a large dwarf galaxy, but the amount of ordinary, light-emitting matter was virtually zero. This could only be explained by a dark galaxy, a structure where dark matter isn't just the scaffolding, it is the entire building. Imagine a galactic-scale mass of this invisible substance, holding together perhaps a few scattered stars or some diffuse gas, but otherwise leaving no mark on the electromagnetic spectrum. It is a cosmic phantom, detectable only by the shadow it casts upon the light of more distant objects. To visualize this, picture a single, straight radio wave traveling from a distant burst. Now place an invisible, massive sphere of dark matter in its path. As the wave approaches, the warped spacetime around the dark matter halo bends the wave's trajectory, causing it to split and take multiple paths around the object before recombining. Our telescopes detect this as a subtle smearing and duplication of the original pulse. It is the universe's way of revealing a hidden giant by showing us how it stirs the pond of spacetime. This discovery, if confirmed, would be monumental. It suggests dark matter can form its own structures independently of stars, gathering into pure halos that roam the intergalactic void. These dark galaxies could be the true building blocks of the cosmos, the invisible foundations upon which the glittering cities of stars are later built. They are the ultimate hidden geography, maps of a universe we can only feel through its gentle gravitational touch. That ghostly dark galaxy reveals a universe built from shadows, but our next discovery is a world of impossible scale, lit by the glow of its own parent planet. The exomoon candidate known as Kepler 1708b is a challenge to everything we thought we knew about moons. Orbiting a gas giant planet over 5,000 light-years away, this is not a small, rocky companion like our own moon. Data from the Kepler and Hubble space telescopes suggest it is a Neptune-sized behemoth, a colossal world of gas and ice that itself could host its own moon. If confirmed, it would be the first exomoon ever discovered, and its very existence breaks the mold. In our own solar system, moons form in two primary ways. They can coalesce from a disk of debris around a young planet, like the moons of Jupiter, or they can be captured by a planet's gravity, like the irregular moons of Neptune. But a moon the size of Neptune that defies both scenarios. A circumplanetary disk simply shouldn't have enough material to build something that massive. The leading theory for this cosmic oddity is a dramatic act of theft. Astronomers propose that Kepler 1708b began its life not as a moon, but as a planet in its own right, orbiting the star independently. In the chaotic early days of that solar system, gravitational interactions could have flung this Neptune-sized world inward, where it was snared by the powerful gravity of the larger gas giant, Kepler 1708b. It was captured, forced into a new life as a permanent companion. Another, even more fascinating idea is that they formed as a binary planet. Imagine two massive bodies condensing from the primordial cloud around the star, not as a star and planet, but as a pair of planetary siblings locked in a mutual dance. Over time, one accreted slightly more material, becoming the dominant Jupiter-sized partner, while the other settled into a stable orbit around it. This would make them more like a double planet system than a traditional planet and moon. Picture an artist's concept of this scene. The gas giant planet fills half the sky, its banded atmosphere swirling in eternal storms. Hanging in the blackness above its limb is the exomoon, a majestic blue sphere streaked with white clouds, a world with its own atmosphere and weather, casting a soft shadow on the cloud tops below. Its size relative to its parent is staggering, a partnership of giants. The search for exomoons is incredibly difficult, requiring exquisitely precise measurements of tiny, periodic dimmings within the already tiny dimming of a planet crossing its star. The signal from Kepler 1708b is tantalizing but not yet definitive, a whisper of a possibility at the edge of our data. Yet its very suggestion opens a new chapter. If such giant moons are out there, they could be havens for life, with tidal heating from their giant planet providing energy to warm hidden subsurface oceans. This candidate forces us to expand our imagination, to consider that a moon is not always a satellite, but can sometimes be a world in its own right, a captured or born partner in a celestial dance of equals. The search for giant exomoons reveals the stunning diversity of planetary systems, but sometimes the universe's most fleeting art is painted in ultraviolet light. Years ago, astronomers stumbled upon a star called TYC 2597761, a seemingly ordinary sun with an extraordinary secret. In ultraviolet images from the Galaxy Evolution Explorer satellite, it was surrounded by a perfect, faint blue ring. For over a decade, this blue ring nebula was a beautiful enigma, a celestial halo with no clear explanation. Recent observations using the W.M. Keck Observatory and sophisticated modeling have finally cracked the case, revealing a cosmic crime scene of stellar proportions. The blue ring is not a ring of gas in the traditional sense, but a vast cone-shaped cloud of debris hurtling outward from the central star. We are looking directly down the throat of this cone, which creates the illusion of a perfect circle. The material within this expanding shockwave is being violently heated, causing it to glow most brightly in ultraviolet light, invisible to our eyes but captured by our telescopes. The source of this chaos was a stellar merger, a few thousand years ago, which is a mere blink in cosmic time. This star was not alone. It was part of a binary system, two stars locked in a close orbit. Over eons, one star began to expand as it aged, eventually engulfing its smaller companion. The smaller star spiraled inward through the atmosphere of its larger partner, a death spiral that transferred immense energy and ultimately triggered the merger of their two cores. The resulting cataclysm blasted the outer layers of the combined star into space, creating the expanding debris cone we see as the ring. To visualize this, look at a multi-wavelength composite image. In visible light, the central star appears normal, a single point of white light, but overlay the ultraviolet data, and that faint, ethereal blue ring emerges, a ghostly echo of the violence that occurred. This object is a precious and temporary snapshot. The expanding cloud is already beginning to dissipate and cool. Within a few thousand more years, the ultraviolet glow will fade, and the ring will vanish from view, leaving behind a single, rejuvenated star that bears the chemical scars of its dramatic past. The Blue Ring Nebula is therefore a once-in-a-lifetime cosmic capture. It freezes a brief, violent phase that most stars in binary systems will eventually experience, but one we almost never get to witness directly. It is the glowing aftermath of a stellar embrace that ended in a fiery union, a brief ultraviolet signature of two stars becoming one. While the Blue Ring Nebula captures a single, violent merger, other stellar pairs are locked in a gentler, rhythmic embrace. Among the most bizarre are the so-called heartbeat stars, binary systems that pulse with light in a perfect, predictable rhythm, as if sharing a single cosmic pulse. Discovered in abundance by the Kepler Space Telescope, these stars orbit each other in elongated, elliptical paths. For most of their orbit, they appear normal. But when they swing perilously close at their point of closest approach, something extraordinary happens. Their mutual gravity becomes so intense that it stretches each star out of its spherical shape, distorting it into a teardrop or egg-like form. This dramatic tidal pull causes the star's surfaces to ripple and heat up slightly, making the entire system brighten measurably before they swing apart again and relax back into spheres. The light curve from these events is unmistakable, a sharp, symmetrical spike in brightness against the steady baseline, a literal heartbeat on an astronomical EKG. But recent discoveries have pushed this phenomenon to a fever pitch. Astronomers have now identified heartbeat systems with pulsations of staggering intensity, where the star's brightness increases by over 20% in a matter of hours. In these extreme cases, the tidal forces are so powerful they do more than just distort the star's shapes. They likely trigger internal seismic waves that ripple through the stellar interiors, churning their layers and mixing their nuclear burning material in ways we are only beginning to understand. Picture this cosmic dance. Two stars, one slightly larger and hotter than the other, follow their elongated celestial tracks. As they reach their closest point, their mutual gravitational grip becomes overwhelming. Their atmospheres reach out toward each other, stretching into elongated bulges. The immense friction and compression at this moment cause their surfaces to glow more fiercely, creating that brilliant flash we see from light years away. It is a dance of distortion and release, repeated with clockwork precision every orbital cycle. These extreme heartbeat stars are not just beautiful curiosities, they are natural physics laboratories. The ferocity of their pulsations tests the very limits of our models for stellar structure and fluid dynamics. How much can a star be stretched before its internal processes are fundamentally altered? Can these tidal interactions transfer enough heat and material to change the star's evolution, potentially extending its life or altering its eventual fate? By studying the precise shape of their light curves, the rise and fall of that brilliant heartbeat, astrophysicists can probe the internal density and viscosity of these distant suns in a way that would otherwise be impossible. Each sharp spike in the data is a direct measurement of gravity's power to sculpt and energize matter on a stellar scale. In the quiet darkness, these paired stars beat like cosmic drums. Their rhythmic flash is a testament to the intimate and transformative power of gravity itself. This rhythmic heartbeat of distant stars is a whisper compared to the silent, pervasive light now found at the very edge of our own solar system. Where the sun's influence finally wanes, a faint and unexpected glow blankets the darkness. NASA Interstellar Boundary Explorer spacecraft, or IBEX, was designed to map the frontier where the solar wind collides with the galactic medium, a region called the heliopause. Instead of just charting this turbulent boundary, IBEX discovered something that should not be there, a diffuse, all-pervasive shimmer of X-rays. This isn't a point of light from a distant quasar or a nearby star. It is a soft, uniform glow that seems to emanate from the entire sky at the system's edge, an enigmatic backdrop to the voyages of our farthest probes like Voyager 1. The immediate, natural suspect is a process known as charge exchange. Here is how it might work. The solar wind, that stream of charged particles rushing out from the sun, finally meets the neutral atoms of hydrogen and helium drifting through interstellar space. When a fast-moving solar wind ion collides with one of these slow, neutral atoms, it can steal an electron from it. That electron, as it settles into a lower energy state around the ion, releases a tiny packet of energy as an X-ray photon. Multiply this by countless trillions of interactions across a vast frontier, and you could theoretically produce the diffuse glow that IBEX sees. It is the faint, crackling static of the solar wind's final interaction with the galaxy. Yet, the observed brightness and specific energy of this X-ray signal are puzzling. Some analyses suggest the charge exchange process, while a strong candidate, might not be energetic enough to account for all of the glow we detect. This discrepancy has opened the door to a far more speculative idea. Could some of this light be a signature of dark matter? One theoretical model proposes that certain hypothetical dark matter particles called actions could be produced in the sun's core. These ghostly particles would stream outward unimpeded. When they encounter the immensely powerful magnetic fields of the sun or the planets, a fraction of them could theoretically convert into low-energy X-ray photons, adding to the observed background glow. While this remains a highly speculative long shot, it highlights the profound mystery of the finding. To visualize this, picture a map of the entire sky in this specific X-ray band. Instead of a few brilliant points, you see a faint, almost uniform, milky luminescence with slight variations in intensity. Superimposed on that map is the lonely trajectory of Voyager 1, a tiny dot now sailing through this very region of soft light. The probe itself cannot see this glow, as its instruments were not designed for such a task, but it is physically there, bathing our spacecraft in a mysterious radiance as it enters the galactic ocean. This X-ray background is a reminder that even the threshold of our own celestial neighborhood holds secrets. It is a final, luminous curtain between the realm of our sun and the vast interstellar beyond, and we are still deciphering whether its light is the last sigh of the solar wind or the first hint of something far more profound. This mysterious glow at our solar system's edge is a frontier of light, but to find the true frontiers of cosmic history, we must look back almost to the very beginning. In a deep-field image from the James Webb Space Telescope, a faint red speck designated HD1 holds a staggering title, the most distant and therefore the earliest galaxy humanity has ever seen. We are observing it as it existed a mere 330 million years after the Big Bang, when the universe was just 2% of its current age. In that primordial dawn, this galaxy should be a faint, infant smudge, struggling to ignite its first stars. Instead, it shines with a brilliant and puzzling intensity, particularly in ultraviolet light. This ancient beacon presents astronomers with an impossible choice, a cosmic riddle with two equally shocking answers. The first possibility is that HD1 is a stellar factory of unimaginable ferocity. To produce the ultraviolet brightness we detect, it would need to be forming stars at a rate that defies all expectations for such an early epoch, perhaps birthing over 100 new suns every single year. For comparison, our own Milky Way galaxy creates maybe 1 or 2 new stars annually. This would be a frenzy of stellar birth, a cosmic fireworks display on a scale we thought was reserved for much later in the universe's evolution. The sheer speed of this process challenges our models of how quickly gas could have cooled and collapsed into stars in those first chaotic ages. The second, even more mind-bending possibility is that HD1 is not a nursery of stars, but the throne room of a monster. Its brilliant ultraviolet light could be the signature of a supermassive black hole, one with a mass over 100 million times that of our Sun, feasting on surrounding matter. The energy released as material spirals into such a gravitational pit would be colossal, flooding the young galaxy with intense radiation. This explanation poses an even deeper problem. How could a black hole grow so massive so fast? In the standard model, these titans start from the remnants of the first stars and grow slowly over billions of years. A black hole of this size, existing when the universe was only 330 million years old, would have had to form almost instantly or feed at a rate that breaks the theoretical limits of physics. It is like finding a giant sequoia tree growing in a field that was only just sown with grass. Both scenarios are profoundly disruptive. Whether it is a galaxy forming stars at an impossible pace or a black hole that achieved impossible size, HD1 forces us to reconsider the timeline of cosmic dawn. The James Webb image itself is a testament to this discovery. In that famous deep field, a tapestry of thousands of galaxies, HD1 appears as nothing more than a tiny reddish dot. Yet that single pixel of light contains a story that pushes our understanding of the early universe to the breaking point. It whispers that the first chapters of cosmic history were not a slow, gentle awakening, but perhaps a period of violent, explosive growth where the rules we take for granted were written in bolder, brighter, and more extreme strokes. That ancient galaxy's impossible brightness forces us to rewrite cosmic dawn. But the chaos of multiple suns is not confined to the distant past. A world with 3 sunsets exists in our galactic neighborhood, a planet named KOI5b. Confirmed in a triple star system over 1,800 light-years away, this is a real-life Tatooine, a testament to planetary survival against all odds. The orbital mechanics here are a masterpiece of gravitational complexity. The planet itself orbits the primary star, Star A, completing a year in just 5 Earth days. But Star A is not alone. It is locked in a relatively close dance with Star B, a companion star that orbits the pair once every 30 years. And farther out, a third star, Star C, circles this inner duo on a much wider 400-year orbit. This means the planet's sky would be a perpetual celestial drama. For parts of its orbit, it would experience single sunrises and sunsets from its primary star. But during other periods, the second star, star B, would appear in the sky as an intensely bright point of light, outshining every other star, casting faint double shadows. And on much longer timescales, the distant third star would glide slowly through the constellations, a constant, brilliant reminder of the system's triple nature. The central mystery is how this planet formed and survived in such a gravitationally tumultuous nursery. In a single star system, planet formation is a relatively orderly process within a calm, rotating disk. In this triple system, the competing gravitational tugs from multiple stars should have stirred the primordial disk into chaos, disrupting the gentle accumulation of dust and gas that builds planets. The leading theory is one of rapid formation and a sheltered orbit. KOI-5b is a gas giant, likely with a solid core. It may have formed incredibly quickly in the very early stages of the system, before the gravitational influences of the other stars could fully dismantle the disk around star A. Alternatively, it might have formed farther out in a more stable region and then migrated inward to its current tight orbit, a journey that somehow avoided catastrophic encounters. Picture this cosmic dance from above. Star A with its planet and Star B whirl around their common center of gravity, their gravitational fields constantly flexing the space around them. The distant third star, Star C, traces a grand, slow circle around this entire inner ballet. The planet itself is a tiny speck, steadfastly tracing its own rapid loops around Star A, perpetually navigating the shifting gravitational hills and valleys created by its stellar companions. Its very existence proves that planets are more resilient than we ever guessed. They can emerge and endure in stellar environments we once considered far too violent and unstable for such delicate construction, finding a precarious balance in a sky filled with suns. KOI-5b's survival in a triple star sky is a marvel of stability, but the early universe was a place of even grander and more precarious architecture. A colossal spine of galaxies, now called the cosmic vine, has been found threading the ancient cosmos. This is not a single galaxy, but a vast filamentary structure, a chain of at least 20 massive galaxies stretching over 13 million light-years. We see it as it existed when the universe was only 3 billion years old, a mere toddler in cosmic terms. The sheer scale and maturity of this structure so soon after the Big Bang presents a profound challenge to our models of cosmic evolution. In the standard picture, the universe starts smooth after the Big Bang, with tiny density fluctuations that slowly grow over billions of years under the pull of gravity. First, small clumps of dark matter and gas form. Then these merge into larger galaxies, which eventually gather into clusters and the vast, web-like filaments of the cosmic web. The cosmic vine should not exist. It is too large, too developed, too soon. Imagine a three-dimensional visualization of this discovery. The screen is filled with a deep, black void representing the early universe. Snaking through the darkness is a luminous, twisting filament of connected points, each point a brilliant young galaxy. The structure looks exactly like a gnarled vine in a time-lapse of a growing plant, but this vine is millions of light-years long and is already fully formed in an epoch when such grandeur was thought impossible. How did 20 massive galaxies line up and connect into this coherent, immense backbone in such a short amount of time? One possibility is that the seeds for these structures were planted even earlier than we thought. The initial fluctuations from the Big Bang might have been more pronounced in certain regions, giving gravity a much stronger head start. Another, more intriguing idea involves the mysterious influence of dark energy. In today's universe, dark energy drives the expansion of space, pushing galaxies apart. But in the very early cosmos, its nature might have been different. Some theories suggest it could have acted as a catalyst, accelerating the gravitational collapse of matter in specific, vast sheets and filaments. essentially fast-tracking the construction of the cosmic web. The cosmic vine, then, is not just an ancient curiosity. It is a fossil from a critical period, evidence that the universe's large-scale structure assembled with a speed and efficiency that our current textbooks cannot easily explain. This gargantuan vine of galaxies forces us to reconsider the very timeline of cosmic construction, suggesting the universe grew up far faster and in far more spectacular ways than we ever dared to imagine. That gargantuan vine of galaxies shows the universe can build with impossible speed, but the death of a single star can create a scene of astonishing destruction. A white dwarf star designated WDJ 0914+1914 should be a pristine, fading ember. These stellar corpses are the burnt-out cores of sun-like stars, and their intense gravity should cause any heavy elements in their thin atmospheres to sink rapidly into their dense interiors, leaving behind only the lightest elements, hydrogen and helium. Yet this white dwarf's atmosphere is shockingly polluted. Spectroscopic analysis reveals clear signatures of oxygen, sulfur, and other heavy metals, elements that have no business lingering on the surface. They are not just present, they are abundant, and they are being replenished. The inescapable conclusion is that this dead star is still feeding. It is actively accreting a rich stream of planetary debris. The source of this gruesome feast is a giant planet, likely similar to Neptune, locked in a devastatingly close orbit. The white dwarf's fierce gravity is exerting tidal forces of unimaginable power on this world, stretching and distorting it, literally pulling it apart. As the planet disintegrates, its material is being siphoned off into a glowing, gaseous disk that spirals down onto the white dwarf's surface. Picture this cosmic cannibalism. The white dwarf itself is a dense, Earth-sized sphere of degenerate matter, shining with a pale, hot light. Whirling around it, at a distance closer than Mercury is to our Sun, is a faint, shimmering disk of vaporized rock and ice, the remains of a once mighty world. From this disk, a constant rain of planetary material falls onto the dead star, contaminating its atmosphere with the unmistakable chemical signature of a murdered planet. This is not a quiet end. It is an ongoing apocalypse. The planet is caught in a death spiral, its outer layers being stripped away with each orbit, a process that will continue until nothing remains but a faint memory of dust and a white dwarf whose polluted glow tells the story of a system that survived its star's death, only to be consumed by the corpse it left behind. The ghostly galaxy NGC 1052DF2 is not alone in its defiance. Meet its controversial twin, AGC 114905, an ultra-diffuse galaxy over 250 million light-years away that appears to follow the same impossible rulebook. Recent, meticulous observations using the Very Large Array Radio Telescope map the rotation of its hydrogen gas, the most reliable tracer of a galaxy's total mass. The results were a near-perfect match for the earlier oddity. The gas was moving too slowly. When astronomers calculated the mass needed to hold the galaxy together, it aligned almost exactly with the mass of its visible stars, leaving no room for the dominant presence of dark matter. The scientific community faced a stark choice, a methodological debate that cuts to the very heart of how we measure the cosmos. Could our measurements be fatally flawed, or are we staring at a revolutionary truth? The primary critique centers on perspective. To measure a galaxy's rotation accurately, we must know its precise orientation in space. If we are viewing AGC 114905 at a steep, nearly edge-on angle, our calculations of its mass from the gas motion would be correct. But if by chance we are looking at it more face-on than we think, the true rotational speed would be much higher, and our mass estimate would be a drastic underestimate. In that scenario, the missing mass, the dark matter, would simply be hidden by a geometric illusion. Proponents of the dark matter free interpretation counter with painstaking analysis. They argue that the galaxy's shape, the distribution of its stars and gas, all point to a highly inclined angle, making the edge on view the most likely. The debate hinges on millimeters of data in radio telescope images, a testament to how precise and how precarious our view of the distant universe can be. The visual contrast is striking. A graph of a normal spiral galaxy's rotation curve shows a steep rise, then a flat line that remains high far out from the center. That flat, sustained high velocity is the direct signature of dark matter's invisible halo, holding the galaxy together. Now, look at the proposed curve for AGC 114905. It rises modestly, then falls away. The velocities drop off exactly as Newtonian physics would predict if only the visible stars were providing the gravity. It is the graph of a galaxy flying apart, or one that has somehow lost its cosmic skeleton. If both NGC 1052DF2 and AGC 114905 are confirmed as genuine anomalies, the implications are staggering. It would mean that dark matter scaffolding is not an inseparable part of a galaxy. It can be absent from birth, or it can be violently stripped away. This would force a major rethink of galaxy formation, suggesting there are multiple pathways to building these island universes, some that require dark matter and some that, against all odds, do not. These faint, puzzling smudges of light are not just celestial curiosities. They are extreme experiments posed by nature itself, testing whether our fundamental picture of the cosmos holds up under the most delicate scrutiny. Carbon, the fundamental building block of life as we know it, is forged in the hearts of stars and scattered across the galaxy when those stars die. But the journey from stardust to complexity is a mysterious one, and a recent discovery has revealed a stunning new chapter. Within the glowing shells of certain planetary nebulae, the funeral shrouds of dying suns, astronomers have found something that should not be possible floating in the harsh vacuum of space: enormous, perfectly symmetrical carbon cages. These are C60 and C70 molecules, better known as buckyballs. Named for the architect Buckminster Fuller and his geodesic domes, a buckyball is a hollow sphere of 60 carbon atoms arranged in a pattern of interlocking hexagons and pentagons, forming a structure that looks exactly like a microscopic soccer ball. For decades, these molecules were a laboratory curiosity, a fascinating form of carbon synthesized under controlled conditions. Finding them in the cold, diffuse expanse of a planetary nebula was a shock. It meant that the chaotic aftermath of a stellar death could, under the right conditions, assemble some of the most complex molecular architecture known to science. The detection was made using infrared telescopes. Each molecule vibrates at specific frequencies, absorbing and emitting infrared light at unique wavelengths. When scientists pointed these instruments at nebulae like TC1, they saw the unmistakable spectral fingerprints of both C60 and its slightly elongated cousin, C70. These are not just any molecules, they are the largest, most complex molecules ever definitively identified in the interstellar medium. Their discovery bridges a critical gap in our understanding of cosmic chemistry. For years, we knew space contained simple molecules like carbon monoxide and water, and we knew it contained microscopic dust grains of silicates and carbon. But the middle ground, the medium-sized organic molecules that could be the precursors to more complex chemistry, was largely missing. Buckyballs are that missing link. They represent a new form of cosmic carbon, a stable, resilient carrier that can protect complex chemistry within its caged structure as it travels between the stars. Imagine a molecular model of C60, a beautiful, symmetrical lattice of spheres and bonds, rotating slowly against the backdrop of a vibrant planetary nebula. The macro and the micro are intimately connected. The dying star at the nebula's center provides the raw carbon atoms blasted into space in its final winds. In the dense, sheltered regions of the nebula's expanding shells, these atoms crash together, and under the influence of ultraviolet light from the hot stellar remnant, they spontaneously assemble into these robust cage-like structures. It is a natural cosmic nanotechnology factory. The significance is profound. Buckaballs are more than just curiosities. They are potential taxis for the building blocks of life. Their hollow interiors could trap other atoms and molecules, shielding them from destructive radiation as they hitch a ride through the galaxy. Some theories even suggest that buckaballs raining down on the early Earth could have delivered exotic forms of carbon or other protected compounds to our primordial planet. They reveal that the universe has a hidden talent for intricate self-assembly, crafting perfect geometric forms in the most unlikely of places, and in doing so, they add a dazzling new molecule to the interstellar inventory from which future stars, planets, and perhaps even life are made. Drifting alone in the perpetual night between stars, a world without a sun paints its own light upon the void. This is SIMP J01365663 plus 09333473, a rogue planet untethered from any star, and it is alive with a magnetic personality. Roughly the same size as Jupiter but over 12 times more massive, this solitary giant wanders the interstellar darkness, yet it defies the expectation of a frozen, dead world. Instead, it possesses a magnetic field 200 times stronger than Jupiter's, and that immense field is generating something beautiful and bizarre, brilliant planet-wide aurorae. The visual is haunting. In the absolute black of deep space, far from the warmth of any star, this lone sphere glows with its own shimmering, multicolored light show. Vast curtains of crimson and emerald ripple across its atmosphere, powered not by a stellar wind, but by the planet's own ferocious internal dynamics. The central mystery is how a free-floating object with no external star to stir its atmosphere or energize its magnetic field can produce such spectacular displays. The answer lies in its rapid rotation and its lingering, searing heat of formation. This rogue planet is a relatively young object, perhaps only 200 million years old. It formed like a star from the direct collapse of a gas cloud, but was not quite massive enough to ignite fusion. It is essentially a failed star, a brown dwarf, ejected from its nascent system to wander alone. That violent birth left it spinning incredibly fast, completing a full rotation in just a couple of hours, and it remains blisteringly hot from the gravitational energy of its own collapse. This combination of rapid spin and intense internal heat drives a churning, metallic interior of liquid hydrogen under immense pressure. This dynamo effect, similar to the process inside Jupiter but far more potent, generates that staggering magnetic field. The aurorae themselves are the signature of this field at work. Charged particles, possibly stripped from a hypothetical orbiting moon or simply present in the thin interstellar medium, are captured by the magnetic field and accelerated down into the planet's atmosphere. There, they collide with gas molecules, causing them to fluoresce in those brilliant colors. It is a self-contained celestial engine, a world that creates its own beauty and fury from the memory of its violent birth. This lonely giant challenges the very definition of a planet. It is not a cold, dark rock adrift. It is a warm, dynamic, and luminous entity, proving that a world can carry its own light and music into the deepest silence, a beacon of magnetic fire with no one to witness its glow. But all these individual oddities, from rogue planets to dark galaxies, may be mere symptoms of a single, underlying crack in our cosmic foundation. The final and most profound oddity is not a distant object, but a fundamental disagreement about the fate of everything. It is called the Hubble tension, and it represents a crisis quietly brewing at the very heart of cosmology. The dispute is over a single number, the Hubble constant. This is the rate at which the universe is expanding, the speed at which galaxies are receding from us for every megaparsec of distance. Knowing this number precisely tells us the age of the universe, its ultimate fate, and the nature of the forces that govern it. For decades, we have refined our methods to pin down this crucial value. The problem is, we now have two supremely precise, yet stubbornly incompatible answers. One answer comes from looking at the local, modern universe. Astronomers use cosmic lighthouses like Cepheid variable stars and Type Ia supernova, whose intrinsic brightness we understand. By measuring how bright they appear from Earth and how much their light has stretched or redshifted, we can calculate both their distance and how fast they are moving away. This distance ladder method, painstakingly built over a century, gives us a very clear, consistent number for the expansion rate. The other answer comes from peering back to the universe's infancy by studying the cosmic microwave background, the faint afterglow of the Big Bang. The subtle patterns in this ancient light, captured by missions like Planck, tell us the exact recipe of the early universe, how much dark matter, normal matter, and dark energy it contained. Plugging these pristine ingredients into our standard model of cosmology allows us to predict what the expansion rate should be today. These two methods should agree. They are measuring the same universe after all, but they do not. The local measurements say the universe is expanding significantly faster than the pristine early universe data predicts. The discrepancy is not a small error bar overlap. It is a persistent, statistically significant gap that has only grown with better data. To visualize this, picture a graph. On one axis is the expansion rate, on the other is time since the Big Bang. The line predicted from the cosmic microwave background starts at the beginning and slopes upward to a specific point today. The line measured from local supernova and Cepheid starts at 0 and climbs steeply to meet today, but it lands on a distinctly higher point. The two lines representing our past and our present do not connect. This is the Hubble tension. It is as if you calculated how fast a car should be going based on its engine specs and the road conditions from its starting point. But when you actually clock its speed with a radar gun, it is moving much faster. Something is wrong with your understanding of the journey. For scientists, this discrepancy is not a failure but a thrilling clue. It strongly suggests that our standard cosmological model, lambda cold dark matter, while incredibly successful, is incomplete. It might be missing a key ingredient. Perhaps dark energy, the force driving the acceleration, is not constant but has evolved, becoming stronger in more recent cosmic times. Maybe there is a new type of neutrino or another exotic particle from the early universe subtly changing the expansion history. Or, most radically, it could point to a flaw in our theory of gravity itself on the largest scales. Every strange object we have explored, the runaway black holes, the dark matter-free galaxies, the impossibly ancient structures, each one is a piece of a larger puzzle. The Hubble tension is the frame of that puzzle, and it is telling us the picture we are trying to assemble does not yet fit together. This is not the end of our understanding, but a new beginning. It is the universe presenting us with its greatest oddity not as a distant spectacle, but as a direct challenge to our fundamental laws, a silent signal that the deepest secrets of reality are still waiting to be uncovered in the space between what we see nearby and the echo of creation itself. From runaway black holes to rogue planets with their own auroras, this tour reveals a cosmos in constant rebellion against our textbooks. Each of these 30 oddities is more than a curiosity. It is a crack in the foundation of our understanding, a place where the universe whispers that our maps are incomplete. The Great Cold Spot and the ghostly dark galaxies suggest a history more turbulent and a structure more ghostly than we dreamed. The impossible chemistry of a single star and the perfect geometry of the red rectangle show that natural processes can craft both chaos and art of stunning precision. The cotton candy planets and the circumtriple world in a shredded disk prove that solar systems form in every conceivable configuration, no matter how fragile or chaotic. And at the largest scale, the Hubble tension itself is the ultimate cosmic oddity, a direct mathematical disagreement between our past and our present that may well be the master key to unlocking a new chapter in physics. This is the true joy of space mystery, not in having all the answers, but in the relentless pursuit of better questions. Every time we point a telescope at the sky, we are inviting the universe to surprise us, to challenge us, and to expand our imagination. So we turn it over to you. After this whirlwind tour of cosmic strangeness, which oddity completely rewired your brain, was it the stellar spider slowly evaporating its partner, or the ancient galaxy shining with impossible light? Let us know in the comments below. If you want to keep exploring the universe's deepest secrets, be sure to subscribe. There are always more mysteries waiting just beyond the edge of our vision. Until next time, keep looking up. The cosmos is far stranger and far more wonderful than we yet